It is a true vector. How? Now I just wanted to prove it mathematically that how it is a true vector. Okay, I just wanted to prove it mathematically that how it is a true vector. Suppose this is your S frame, suppose this is your S prime frame, and your S vector. Okay, S vector, what is your S vector? Displacement vector. I just wanted to prove how it is not changed mathematically. So suppose there are two sets of points. This is point P. It is displaced from this point R1 vector. This is suppose, let's say R1 vector, to another point R2 vector in the frame of reference of S. And the same point P is moved from R1 prime vector to R2 prime vector from the reference frame of S prime. So this point is moved from this point to this point, and this is your S vector. Now, okay, this is your S vector. I will not write arrows in vectors. I'll just write bar. Both are same thing. You can write whatever notation you want. Yes. So now S vector is defined as R2 prime minus R1 prime. If we see from S prime axis, this is how we define S vector, right? From the, it is a vector. Okay, let me draw a very nice figure to actually explain. This is the nice figure. This is your R1 vector. This is your R2 vector. And if you will see, if you will apply triangle addition laws, then you will see that R1 vector plus S vector is your R2 vector. Can you see this?
Yes, sir.
Yes, sir.
It means that S can be defined by this R2 minus R1. And similarly, you can also define this. Similarly, you can define this. That this is your R1 prime vector for the same point. This is your R2 prime vector. And now you can see R1 prime plus S is R2 prime. So again, S is R2 prime minus R1 prime. Okay, so you can see that S is R2 prime minus R1 prime. So you can see where if you can write S as this as well as this as well. So even if you change the coordinate systems, the S is not changing. And I want to prove that both of these guys are the same, R2 minus R1, or okay, let's write this as S prime. Well, let's write this as S prime, that is displacement from primed coordinate, and this is displacement in unprimed coordinates or unprimed reference frame. Now let's try to prove that S and S prime are equal. How to prove that? We know that this is R2 prime minus R1 prime. From this diagram, what do we see? From this diagram, we see that R plus R prime is R. Can you see this? This R is the distance, actual R, what is R? It is the displacement vector between these two reference frames in itself. So you have two reference frames, between them you have a displacement. This R is that displacement vector. The displacement between these two reference frames is given by R, and the point of coordinate, so position vectors are R prime and R from two different coordinate systems, and you can see this result being applied here. And if you can see this result, you can immediately see this R1 prime or just R prime. It may be it R1 or R2 or whatever. R prime can always be written as R minus R. Can you see this?
Yes, sir.
And if you can see this, then you will not be surprised if I write this as R2 vector minus R vector minus R1 vector minus R vector. And if I write it like this, then it is, this is our S prime, right? This is our S prime. It is this. It is R2 minus R1. This RR will get cancelled out. And this is nothing but S vector. So you know that even if you change the frame of reference, this S vector will not change. This is the mathematical proof. That S vector will not change wherever you change the reference frame. If you know that they are being changed by a constant amount. If this amount is different, this R is varying by itself, then the things are different. Okay, can you see this or not? Any questions till this point? As I already told you, we'll be moving on to a little bit higher dimension. It will be a difficult course if you will not go through HCV book. Okay, just read the theory. I don't want you to do problems from there. We will anyways do some good problems in the classrooms. I just want you to do theory there. So just read theory of HCV of whatever portion I'm going to teach before coming to the class. From HCV, from NCRT, whatever you feel preferable.